I'm glad to have all of you who are still here with me. I ran a Twitter poll asking for input, and per that poll, I will continue using The Witcher as the backdrop while I talk about today's advanced and mathematically complex topic, the Banach Tarski paradox. The Banach Tarski paradox is part of theoretic geometry, which, simply put, it is a mathematical explanation on how a three-dimensional object can be disassembled, and from the pieces of that one object, two more objects can be assembled. Objects that are not only identical to each other, but also identical to the original object that was disassembled. Which is impossible, right? Technically, yes, but also no. The Banach Tarski paradox, or simply BT paradox as I will refer to it for the rest of the video, so I don't butcher the pronunciation too much. Anyway, the BT paradox is physically impossible, yes. But mathematically, not unreasonable. Let me explain. For example, we disassemble an object. Arbitrarily, the dwarf planet Ceres from the depths of our solar system. Ceres is disassembled into pieces, and all of those pieces are cataloged on a graph with x, y, and z axes so that they may be cataloged. Next, you take all the points along all three of these axes so that there are all the points that have a zero in them, and you throw them out because this is math, and zero is a true absolute nothing, so zero can be ignored. The extra decimal point dropped off. That's why saying 1.00000 is the same as saying 1. Anyway, so all these 0-point energy field manipulators wrong topic, wrong discussion. All of these 0-point locations on the graph can be discarded without making a mathematical difference. You ignore them entirely. Yet all of those locations are real physical parts because we disassembled Ceres. So what do we do with all these extra 0-point parts? We can just reassemble them into another Ceres, right? That's how it works. Does that make sense? Just in case, let me try a different alliteration. Because, see, the trick is you have to be able to count to infinity. And that's where the paradox arises from. Because mathematically, you can count all of those zero locations, but in reality, you can't, because they are physical parts of the disassembled dwarf planet Ceres. But if you could count to infinity, there would be infinite parts, an infinite number of even-numbered parts, an infinite number of odd-numbered parts, an infinite number of 0-point parts on that graph, so on. In theory, it's possible, but only if you can count to infinity, and do so repeatedly. In simplest terms, it's basically said that if you have an infinite number of parts, and separate that into two equal portions, both portions will be the same size as the original, because they will both still contain an infinite number of parts. Because even if you have 1.00001, you can always go to 1.000001, and so on. If you're following me still, think of all the industrial applications of this. If you could count to infinity, if you could make two things out of one thing, imagine what we could build with that. Your one hand-built, perfectly fitted prototype would be all that's ever needed. And then it would just be duplicated. And that duplicate would be identical to the hand-built model in every way. If it had to be tweaked just right so that the prototype was exactly perfect, and then there'd be no need to tool up for mass production. Pretty soon, duplicates would be produced out of thin air. I see something like a 3D printer, but instead of loading it with a media that you want to print with, you put in whatever object you want duplicated, and it gives you two. So then my question is, what happens if you split this new duplicate object? I mean, I see no reason why, mathematically, you couldn't make an infinite number of copies of something. But part of me also feels like that would be too easy. It can't work out that nicely. Entropy and all that. Maybe, all the subsequent copies would just have worse and worse luck associated with them. I mean, sure, it's measurably identical, but then it's going to have bad luck and break the first time you use it because it's a 1000th generation copy. However, I've also never heard of this theory being applied to any shape other than a sphere. But for the interest of science fiction, I'll allow it to be applied to other things too, since the rule of good science fiction is you're only allowed to break one rule of the laws of physics per franchise. Unfortunately, because it's a paradox and it's not physically possible to do this, because we can't count to infinity, because once you count that high, there's always another number. I mean, you can't even count from 0 to 1, because there are an infinite number of decimal values of whole numbers between 0 and 1. That's a different mind-bending topic. Mind-bending topic. A different dilemma for a different video. Anyway, it's a paradox because it's physically impossible, yet the math says it is. The math speaks otherwise. So, there you go. I hope I sparked your interest, confused you a little bit, shed some light on the topic. Yep, thanks for bearing with me, and I hope my microphone settings came out a little better this time. And I look forward to seeing all of you in the next video. Different game, different topic, as I continue to try and explain the science inside of science fiction.